Okay, so in our previous class, we covered the port security. Now, in today's class, we are going to cover some small topic that is related to the security. Okay, so the first topic that we are going to discuss that is port first. That is port first. Now, first of all, we need to understand what is port first and actually what is the use of port first. Clear? So, port first means, please focus here. This is a Cisco feature that allow an access port to transition immediately to the forwarding state by bypassing the usual STP state. So basically, this is the use of port first. First of all, try to understand what is the problem and how this problem is solved by port first. So once you will understand the problem, then you can understand the solution very easily. For example, this is switch number one, switch number two, and both switches are connected like this. Here, this is PC. So for example, this is switch number one, switch number two, and PC. Now, I hope you have some idea if you already watched the STP videos. Here between the switches, we are using STP, right or wrong? Right? Between the switches, we have a concept of STP. Why? Because between the switches, there is a high probability to create the loop. Yes, na? Yes, between the switches, there is high probability to create the loop. But what about this? This is PC, and here there is a switch. Clear? So from PC side, switch is not expecting different packets, or I mean, switch will accept only one packet from PC side. I mean, from only one VLAN. Getting my point? But from PC side, it means that is the end user side. So here basically there is very less probability to create the loop. But between the switches, there is high probability to create the loop. So at layer number two, I mean at L2 level, there is a concept of STP that prevent the loop. Clear? So that is the first thing. Second thing, this is the PC. And if you have idea in STP, basically there are multiple states. For example, disable state, blocking state. Next is listening state. Next is learning state. Next is forwarding state. So basically these are the states of port. Port state means, for example, this is the switch. And for example, this is the interface of the switch, fast Ethernet 0 by 0. When you shut down this interface, and then no shut down it will take how much time? 30 seconds to get up. To get up, I mean in the forwarding, to come in the forwarding state. For example, I can show you this one. See here. For example, this is the switch. For example, any switch. For example, this switch. The interface is fast Ethernet 0 by 1. Okay. So I go on fast Ethernet interface, fast Ethernet 0 by 1. I write here shut down. See, this port goes down. Now I am writing no shut. So when I write no shut, this port is not in the forwarding state right now. See now, what is the color here? This is orange color. It means this is not in the forwarding state. It will take total 30 seconds to come in the forwarding state. When this port will come in the forwarding state, its color will be green. Getting my point? But right now, this port is not in the forwarding state. Getting my point? I can show you also. Show spanning tree VLAN 1. VLAN 1. See, it's green. So that's the reason now you are able to see its state is forwarding. Its state is forwarding. But interface fast Ethernet 0 by 0 shut and no shut, and so spanning tree VLAN 1. See, you are able to see a different state. That is the listening state. LSN means that is listening state. After listening, it will go in it will go in different state. After listening, it will go in learning state. It will go in SINA, LRN. It means now it is learning state. After learning, it will go in forwarding state. Getting my point? Yes or no? Understand na? Yes, see now still it's in learning state. Now it is in forwarding state. So total how much time it's take? It is taking total 30 second. It is taking total how much time? It is taking total 30 second. I hope this is clear, right now? So please remember, if on a switch, if any ports goes down, by default, it's take total 30 second to come in the forwarding state because of multiple port state. Multiple port states. Basically, there are multiple states. For example, first one is disable. Then your switch port will move in which state? Blocking. After blocking, it will move in listening. After listening, it move in learning. And after learning, it move in forward. Clear na? Here, from listening to learning, it will take 15 seconds. And from learning to forwarding, it will take 15 seconds. So that's the reason overall time is 30 seconds. I hope this is clear to all of you, everyone, right? So that's the reason whenever switch port will get up, it will take total 30 seconds. Yes, Nirodin, exactly. So, but try to understand, for example, if this is the switch and with this switch, these PCs are connected or any end users are connected. Do you think in the real time environment, we need to wait for 30 seconds and we can wait for 30 seconds in the real time, because 30 seconds is very big in the real time environment. If there is a 30-second delay, that will be very big outage. Getting my point? So that is, we can't afford the 30-second delay, guys, in the real time environment. Getting my point? Understand, guys, everyone? Yes or no? Right now. So how can we mitigate this type of problem? How can we solve this type of problem? Getting my point, everyone? So the solution is, in switching, there is a one feature and the name of that feature is called port fast. What is the name of that feature, guys? The name of that feature is called port fast. Getting my point? So here on switch end, what is happening? Your end device like your PCs, your printers, your phone. So it will take 30 seconds to get in the forwarding state, to come in the forwarding state. So basically this type of delay is unnecessary. Getting my point? This type of delay is unnecessary. And in the real time environment, we can't afford this type of delay. So basically port fast help us by solve this or you can say mitigate this type of delay. Clear? So basically, wow, what port fast will do? What port fast will do? For example, if I enable the port fast, what exactly port fast will do? And how actually the port fast will work? So please remember, when you configure the port fast, what will happen? Your switch port immediately transition from disable states to forwarding state. In which state, guys? Forwarding state, without waiting for 30 seconds. Without waiting for 30 seconds. Getting my point? Understand, everyone? Yes or no? Right now. So after configuring the port fast, now your port will immediately move from disable states to forwarding state. It will not participate in different states. But if you do not configure the port fast, your port will go in the disable, learning, listening, every state. But now port will go immediately in forwarding state. I hope this is clear to all of you. Right, guys? Everyone? Yes or no? Right? Now the thing is, how we can configure. How can we configure the port fast? So I'm writing the command, guys. Please focus here. The command is, for example, if I want to configure port fast on fast Ethernet 0x0. And guys, one thing that you need to remember, guys, port fast feature, we are enabling this feature only on the access port, not trunk port. Trunk port means between the switches, we are not configuring port fast. We are not configuring port fast. We are configuring port fast on access port where end users are connected. Getting my point? Understand? So for example, this is fast Ethernet 0x0 port. For example, this is fast Ethernet 0x0 0 port. So on this port, how you can configure? You go on interface fast Ethernet 0 by 0 and then write spanning tree port first. Port first. Spanning tree port first. Getting my point, everyone? Yes or no? Right now. So please remember, by the help of this command, what you are doing? You are this enable the port first feature on this specific port. Please remember this line. If you write this command, so interface fast Ethernet 0 by 0, what will happen, guys? Basically, by the help of this command, you are enabling the port fast feature on any specific port that is fast Ethernet 0 by 0. Getting my point, everyone? Yes or no? Right? But for example, if anyone is telling you, ki, hey, on this switch port, for example, there are 48 ports are there or 24 ports are there. Could you please enable the port fast feature on every port? You can say, yes, we can do. We can do, but how? So see, if you want to enable this feature on all the switch ports, then what is the command, guys? You do not need to go on any interface. You need to go in global configuration mode. Where, guys? In global configuration mode, write the command spanning tree port fast default. So this is the command. When you configure this command, by default on every port of the switch, port fast feature will be enabled. Clear, guys? I hope everyone understand. Clear? See here. For example, here this is the switch port. This is the switch port, fast Ethernet 0 by 3. Agree? So when a minute, what happened? Okay, guys. So see here, guys, in this topology, here who is connected? Our end users are connected, and this is our switch, right? And this is called switch port, right? So this end user is connected with interface fast Ethernet 0 by 3. Getting my point, everyone? Yes or no? Right? Now I go to the switch, enable conf t interface fast Ethernet 0 by 3, and I write shutdown. This port is now down. Now I am writing no shutdown. This port is now up. Getting my point? This port will take how much time, guys, to get up? 30 second. Total how much time, guys? Total 30 second. Getting my point, everyone? Yes or no? Right now. But again, this is the problem. See now, it is still not in the forwarding state. It is still not in the forwarding state. And if it is not in the forwarding state, it will not forward your packet.
Teacher, do you listen me?
Yes.
Can you check if the recording is working?
Yes, recording is working. Fine.
Okay, thank you.
So guys, it will take total how much time? 30 seconds to get up and to come in the forwarding state. So that's the reason I told you, in the real-time environment, we can't afford this type of delay. So what is the command, guys? How can you enable the port fast feature? The command is, first of all, you need to go interface fast Ethernet 0 by 1. Sorry, 0 by 3. This is the port. Interface fast Ethernet 0 by 3. Now write spanning tree port first. Spanning tree port first. Now I enable this port. Getting my point, everyone? Yes or no? Now I enable what? Port fast feature on this port. Getting my point, everyone? Yes or no? So interface fast Ethernet 0 by 3. When you see here, maybe you guys will able to see port fast feature is enabled here. If you see this line very carefully, maybe. So running configuration. On packet tracer, we can't run, but yes, by the help of these commands, you guys can check the running configuration. Okay, no problem. Now, go on interface fast Ethernet 0 by 3. I am writing shutdown, then writing no shut. Now see, immediately your port is now moving in the forwarding state. Everyone, yes or no? Right now your port is not taking 30 seconds. Now your port is immediately getting in the forwarding state. But before port fast feature, it was taking how much time, guys? It was taking 30 seconds. Is this clear, guys? Everyone, yes or no? I hope you guys understand port fast feature. Clear? Is this clear? Yes.
Yes.
Now, guys, second security feature is called BPDU guard. What is called, guys? That is called BPDU guard. What do you mean by BPDU guard? What do you mean by BPDU guard? See here. The name of that concept is BPDU guard. Okay. BPDU guard. Guys, first of all, if you are trying to understand BPDU guard, first of all, understand BPDU guard is a Cisco feature that automatically disable a port fast enabled port if it receive a BPDU to prevent network loop. See what I written? I written if your switch receive any types of BPDU on port fast enabled port fast, where we enable port fast, guys? We enable port fast on access port right now, where end users are connected. Getting my point? Yes or no? So in this case, what switch will do? Switch will automatically disable that port. Understand the scenario. For example, this is the switch. This switch is connected with this switch. This switch is connected with this switch. And with this switch, for example, PC is connected. Now tell me one thing. Between the switches, there is a one packet that is called BPDU. Right now, if you guys have some knowledge about the STP, switches are exchanging, guys, one packet. The name of that packet is BPDU, right? Because among these three switch, one switch will become, guys, root bridge, right? And how root bridge will elected? For example, this is me, this is Ahmad, this is Nuruddin. If we all are participate in the election, among all the three, any one of them, guys, will won the election. Yes or no? Right now, right? Anyone will won the election. But how you decide who won or who lost? There will be definitely some parameter. For example, in election, we have a parameter like vote. Right now, we are counting the vote, and on the basis of number of vote, we can decide कि hey, this number, Nuruddin has highest number of votes, so Nuruddin won the election. Getting my point? Yes or no? Right now, so there is a some parameter. In the same way, if multiple switches are connected, how among these three switch, one switch will become a root bridge? Definitely there will be a parameter. Getting my point? The parameter is different parameter, guys. Okay, but the question is, this switch has its own parameter, this switch has its own parameter, and this switch has its own parameter. Now, how this switch will understand and how this switch will get to know what is the parameter of this switch and what is the parameter of this switch? And once this switch will understand कि hey, my parameter is XYZ, this switch parameter is ABC, and this switch parameter is, for example, GEF, then this switch will compare all the parameter. And among all the parameter, this switch will check, oh, among all the three parameter, my parameter is best. It means I will become root bridge. Getting my point, everyone? Yes or no? Right now? But again, there is a thing. How this switch will get to know what is the parameter of this switch and this switch? Definitely, there will be any packet. There will be any packet. Getting my point? And in this packet, these parameter will exchange. Getting my point? And the name of that packet is called, guys, BPD. Anyone here who do not understand BPDU? I hope this is clear, right? Understand? So BPDU is nothing. BPDU is just like a packet. In this packet, switches exchange its parameter, and on the basis of that parameter, among all the three switches, one switch will become root bridge. one switch will become root bridge. Getting my point? Yes or no? Right now. So this is the first thing. Second thing, I have very simple question. Guys, tell me one thing. Here, root bridge will elect among these three switch. Agree, everyone? Yes or no? Right now. Now, is there any possibility this PC will become root bridge? Answer is no. Guys, PC is end user. So at PC end, I already told you there is no chance to create the loop. Getting my point? At PC end, there is no chance to create the loop. So at PC end, guys, PC will never become root bridge. Getting my point? So among these three switch, one switch will become root bridge, and it will decide on the basis of parameter, and that parameter will exchange by the help of packet. The name of that packet is Bpdu. Fine. Now, in the same topology, switch 1, switch 2, switch 3, and here PC is connected. Now, I already told you this PC will never become the root bridge. It means this switch will receive the BPDU, this switch also receive the BPDU packet, and this switch also receive the BPDU packet. Now, my question is, this switch will receive the BPDU from switch number 2 and switch number 3. Agree, yes or no? Right? It means switch number 1 is expecting a BPDU from switch number 2 and switch number 3. Similarly, switch number 2 is expecting a BPDU from switch number 1 and switch number 3. Agree, yes or no, everyone, right? Similarly, switch number 3 is expecting a BPDU from switch number 2 and switch number 1. Yes or no, right? But if I ask you, does switch number 3 is expecting a BPDU from PC also? My answer is no. No, guys, no. Because BPDU, I already write here, na. BPDU is a Cisco feature. Do you think Cisco is manufacturing the PC device? No. Cisco is not manufacturing your computer, your laptop, guys. Getting my point? Cisco is manufacturing the networking device, not end user device. Getting my point? Yes or no? Right? So, from PC side, this switch is not expecting a BPDU. Getting my point? Yes or no? Right? But for example, if there will be any scenario, for example, any guy go to the office. For example, any guy, this is the guy who is going to office with laptop, with laptop. So that is fine. And this guy came to the office and connect its laptop here with this port, and everything is working. There is no problem. Suddenly one day, this guy become mad. And what this guy did, this guy purchased one Cisco switch and go to the office with switch and connect this switch with this port. What will happen? When this guy connect this switch with this port, it means now this switch number 2 start receiving the BPDU from this switch on this port. Agree, yes or no? Everyone, right? Everyone, right now. And on this port, previously you already configured the port fast feature, because this is the end user port, right? I already told you we configure the port fast feature on end user port or access port. So on this port, you already configured the port fast. But on port fast enabled port, now switch number 3 is start receiving the BPDU. That switch number 3 was not expecting. Getting my point? And if switch number 3 is receiving the BPDU on port fast enabled port, then switch number 3 will understand, hey, definitely something is going wrong. Something is going wrong. I configure this port for end user. I configure this port for end user. I didn't configure this port for any networking device. But I am receiving the BPDU here. It means definitely there is something goes wrong. So immediately what switch number 3 will do? Switch number 3 will disable this port. Switch number 3 will disable this port. And guys, this is possible because of one feature, and the name of that feature is called BPDU guard. So please remember, on port fast enabled port, or I can say the access port, what we are doing, we are enabling one feature, and the name of that feature is called, guys, BPDU guard. Because on that port, we are not expecting any types of BPDU. Getting my point? Is this clear to everyone? Yes or no? Right now. So this is called, guys, BPDU guard. Clear? Anyone here who do not understand? Let me know. Clear now? Yes. Yes, cool. So, for example, if on any port, if you enable the BPDU, if you enable the BPDU guard, and if on that port switch will receive any types of BPDU, what and how this port will behave. So please remember one thing: if your port receive the BPDU on port first enabled port or on access port, what BPD, what switch port will do? What switch will do? Switch will
Forwarding.
immediately disable that port. Disable means your port will go in error disable mode. Your port will go in which mode, guys? Error disable mode. And second action switch will take, switch generate a syslog message to notify the network administrator. Getting my point, everyone? Yes or no? So basically, when you configure the BPDU guard, this is the steps, or this is the action BPDU guard will take. Clear? Now, what is the command to configure the BPDU guard? So please remember, go on interface fast Ethernet 0 by 1, and write the command. What is the command? Spanning tree guard enable. So basically, this is the command by which you can enable the BPDU feature, BPDU guard feature on any specific port. Getting my point? Yes or no? If you want to enable this feature on every port, then you can run the command. Which command? Same command, guys. Enable, snapping tree port fast BPDU default. This is the command. But generally, we are not configuring this command, guys. In real time environment, also, we are not configuring this command, right? Because we do not want to configure this feature on every port. Getting my point? Because only on access port we are not expecting, but between the switches we are expecting. So we can't configure BPDU feature between the switches. So what was the command, guys? Spanning tree port fast BPDU guard default. So basically, this is the command. If you want to enable on every port, you can run this command. Clear, guys? Everyone? Yes or no? Done, na? So for example, we are here. So guys, on this port, we already enabled the port fast feature. Yes or no? Everyone, tell me. Anyone who do not understand, let me know.
It's clear.
Yes, clear. So this is the command I already configured here. What, guys? We already configure which command? Port fast command. Are yes or no? Right na? Guys, yes or no? Right na? Yes. We are not able to check here in the packet tracer, but in the real time environment, you can run the command and you can check here the port fast feature. Okay. Even let me check this command if work or not. So spanning tree interface fast Ethernet 0 by 3 port fast. Yes, see, port fast is enabled. Agree, everyone? Yes or no? Right na? So by this command, you can check port fast is enabled or not. Done, guys? Everyone, tell me. Right now, guys, next thing is we are going to configure here what? BPDU guard. Clear na? So what is the command, guys? Again, go to the global configuration mode. I am writing interface fast Ethernet 0 by 3. Interface fast Ethernet 0 by 3. What is the command? Spanning tree BPDU guard enable. I told you na, this is the command by which you can enable the BPDU guard. Clear, guys? Yes or no? Tell me. Everyone. This is the same command I told you. What is the command? Again, see, if you guys are writing, please write down the command. Spanning tree BPDU guard enable. Please don't forget this command. Clear? So basically, by this command, what we can do? We can enable the BPDU guard. Clear? Yes. Now, for example, here on this port, switch is not expecting any BPDU. And right now in my topology, here we connected here PC. And PC is not the Cisco device. So this PC is not going to Forward, what guys? BPDU. Yes, that is the command to enable the BPDU. Yes. So guys, this PC is not going to share any types of BPDU. So in this scenario, that is fine. But for example, if I change the scenario, getting my point? If what I am doing, see here, guys, I go here and I remove this PC from here. And now what I did, I connect one switch here on fast Ethernet 0/3. Now, once I connect, see what happened. Once I connect one switch here on this port, see na, show interface fast Ethernet 0/3. What is the command, guys? Show interface fast Ethernet 0/3. What is? Your port is now down. Your port is down because of your port is now in which state? Error disable state. Your port is now in which state, guys? Error disable state. Getting my point? Why your port is now error disable state? Because on this port you already configured what? BPDU guard. You already configured here BPDU guard. And if you configure the BPDU guard here, you are not expecting any types of BPDU because this is the access port. And on this port, only end user should be connected. But what you did, you configure any switch. So this switch is sending the BPDU. And once this BPDU is received on this port immediately go in error disable mode. In which mode, guys? Error disable mode. Getting my point, everyone? Yes or no? Tell me, is this done? Everyone, I hope you guys understand. Clear now? The line is down. Yes, exactly. This port is now down. Clear? But once I go, I remove this port here. I just switch here. I connect again one PC like this. Let me check what is the IP address we configured there. We didn't configure any IP address yet. But see, once I connect this PC here, now I go on this port conf interface fast Ethernet 0/3 shut no shut. So I told you na manually if you want to remove the error disable you can do shut no shut. Yes or no? If you guys remember in previous class I told you. Right now? Yes, that command to enable the correct the line is down is because of the error. Yes, exactly. So now see, now you go on this port show interface fast Ethernet 0/3. Now see your port is up. So I hope now you guys understand why that port was down because of guys because of this port received the immediately what? Arey, what? This port receive immediately BPDU right now, and on this port switch is not expecting any types of BPDU. Getting my point? Yes or no? Right now? Yes. So this is the thing, guys, about the BPDU guard. I hope you guys understand. Clear? Now, guys, next concept is that is called root guard. What is called, guys? That is called root guard. What do you mean by root guard? What do you mean by root guard? See here, guys. Root guard means it is a Cisco feature that prevent unauthorized switch from becoming the root bridge in STP network. This ensure that STP is stable in your network. Getting my point, everyone? Anyone here who do not understand, let me know. Clear na? So basically, guys, in root guard is the Cisco feature. Basically, for example, if there are three switches, switch 1, switch 2, and switch 3. And for example, this switch is high configuration switch. So definitely you will configure this switch as a root bridge? Yes or no? Right now, I hope you guys have some idea about the STP. Then I hope you guys know what is root bridge. Basically, root bridge will take every decision here in this network. Right now, so root bridge should be the high configure device, guys. Right now, so this is the root bridge. Now, we do not want any other switch will become the root bridge. We do not want any other switch will become the root bridge. So what is the solution? The solution is the root guard. We will configure the root guard feature here on this switch. We will configure root guard feature on this switch. So once you will configure the root guard feature on this switch, any other switch will not become the root bridge. Getting my point, everyone? Yes or no? Right now, everyone? Yes. So basically, in STP, if you remember, in STP, any switch will become the root bridge on the basis of some criteria. I already told you, na.
Bridge
There are,
ID.
yes, there are some criteria. Getting my point? So the criteria is
Bridge
bridge
ID.
priority plus MAC address, and that is called bridge ID. Right now? Yes or no? That is
Yes.
called bridge ID. So please remember, switch always prefer lowest bridge ID. Switch always prefer lowest bridge ID. It means the switch whose bridge ID will be lowest, that switch will become the root bridge. Getting my point? Yes or no? And you know, the root bridge is the critical because all the switches determine the best path based on it, right now. So that's the reason root bridge is very important. So if any unauthorized device or any misconfiguration will happen in your network, then what will happen? The switch with a lower bridge ID, it will become the root bridge. For example, this is the topology, and in your topology, everything is fine. This is the root bridge. For example, anyone came here with this switch, and what that guy did, that guy configured this switch with the lowest bridge ID. So immediately what will happen? This switch also sends the BPDU. Yes or no? Right now, this switch also sends the BPDU. So this BPDU reach here. This switch already have BPDU from here also, here also, here also. So this switch have total 3 BPDU. Right now, so this switch will compare. Oh, among all the 3 BPDU, this switch has better BPDU. Getting my point? Similarly, this switch will check. So now, once this switch will check, this switch will can understand ki, oh, this switch has better BPDU than me. It means this switch should become the root bridge. And by this way, this switch will become root bridge. But this is the unauthorized switch. Yes or no, everyone? This is the unauthorized switch for you. You do not want any other switch will become the root bridge except this one. Getting my point? So you can protect your root bridge by the help of this feature that is called root guard. That is called, guys, root guard. Clear, guys? Everyone? Yes or no? Right? Now the thing is, how actually root guard works? How root guard work? How root guard work? So please remember, the port operates normally as long as it does not receive any superior BPDU. Guys, superior BPDU means better BPDU. And who is better BPDU? The BPDU who has lowest bridge ID. Right now, that BPDU will become the superior BPDU. Now, point number 2, if the port receive a superior BPDU, if a port receive a superior BPDU from any other switch that want to become root bridge, root guard will take the action, root guard will take the action and block the port immediately. And in which state, guys? That is called root inconsistent state. In which state, guys? That is not error disable. That is the name of this state, guys, root inconsistent state. Getting my point? Everyone, yes or no? Right now? Yes. Clear, guys? Anyone here who do not understand? Done na? Everyone? Yes or no? Right now? Yes. It will move your port in which state? Root inconsistent state. Clear na? Now, again you guys will think, sir, till when? Till when? So please remember, the port stay blocked until the superior BPDU stop receiving on that port. Until the superior BPDU receive the port. Once the superior BPDU stop, your port will come in the forwarding state. Clear na? Yes na? Yes or no? Yes. Clear guys? Everyone? Yes na? So once the issue is resolved, once the once switch stop receiving the superior BPDU, your root guard will automatically re-enable the port. Getting my point? Understand? So guys, this is called root guard feature. Now, how can you configure this root guard feature? The same command, guys. Go on interface fast Ethernet, for example, 0 by 0. If you want to enable root guard feature on this port, then write the command spanning tree guard root. This is the command. So basically, by the help of this command, you will enable the spanning tree root guard feature on this port. Clear, guys? Everyone, yes or no? Right now, for example, in our topology, come to this switch. See here, I'm writing the command show spanning tree VLAN 1. By default, VLAN 1 is there. What is this line, guys? This bridge is the root. It means this is the root bridge. This switch is a root bridge. This is the root bridge, guys. Sorry, this is the root bridge. This switch is called root bridge. Done, guys? Yes or no? Right? Now, if this is the root bridge, it means all the port is in which state? Forwarding state by default. I hope everyone know. Right now? Yes. It means this switch is forwarding the BPDU. This switch is forwarding the BPDU after every 2 seconds. Clear na? Done? Now, for example, we do not want any other switch in our network should become the root bridge. What we can do? Who can tell me? What we can do? Do you understand my concern, guys? Yes, if we do not want any other switch will become the root bridge, what we will do? We will configure here, guys, one feature. The name of that feature is root guard feature. Right now, so here we have a 2 port fast Ethernet 0 by 1 and 0 by 2. So see here, how can we enable the root guard feature? Conf t, I need to write interface range fast Ethernet 0 by 1 to 2. Fine, because I am going to write configure this feature on both port. Getting my point? So what is the command I told you, guys? Spanning tree guard root. This is the command I told you. Everyone, yes or no? Right? So what I did on both port, I configure the root guard feature. Clear na? Guys, again you guys will think, sir, can I configure the same command on these port? My answer is no. Why you configure? Why you need to configure? Who is the root bridge in your network? This is the root bridge. So you need to protect your root bridge. These are not root bridge. So why you need to configure? There is no need. Getting my point? The motive of this command is to protect the root bridge. Right now, these are non-root bridge. So why you need to configure this command here? No need. Getting my point, everyone? Yes or no? Done na? Okay, cool. And guys, I already show you this switch is a root bridge. Right now, how can you check? Show spanning tree VLAN 1. By default, VLAN 1 is there, guys, on every switch. Right now, so see na, this bridge is the root. It means this is the root bridge. Now, for example, what I want to do, for example, I connect one switch here. I connect one switch here like this. I connect one switch here like this on fast Ethernet 0 by 4. I connect this switch on different port, guys. I didn't configure this port on this port. If I configure here, then again this port will goes down. Why? Because on this port, I already configured, guys, port fast feature as well as BPDU guard feature. Right now, so on this port, switch is not expecting the BPDU, but this is a different port. So here, there is no problem. Here we can connect this switch. Getting my point, everyone? Yes or no? Tell me fast. Right? Yes. On this port, what is happened, guys? On this port, I didn't configure any types of feature. Getting my point, everyone? Yes or no? Right now? Yes. So I go on this switch and I want this switch has better BPDU. Again, I'm telling, I want this switch should have better BPDU than this switch. Getting my point, guys? Previously, try to understand. Previously, ignore this switch. Previously, there was three switch. This switch here, it's on BPDU. This switch here, it's on BPDU. So among all the three BPDU, this switch has better BPDU. That's the reason this switch was root bridge. That's the reason this switch is the root bridge. Now what I want, I will change priority of this switch. So this switch has better BPDU than this switch. So this will send the BPDU, this BPDU will receive here. This BPDU will reach here. So once this BPDU will reach here, your port will go in root inconsistent state because you already configured here root guard, because you do not want any other switch will become the root bridge. But now manually I am trying this switch should become the root bridge. Now see what will happen. See here, I go to this switch. What I'm trying to do, I am trying to, for example, host name. This is the hacker. Okay. I am writing spanning tree VLAN 1 priority. What is, guys? Priority. Okay. Now, before this, please understand. Come to this switch. If I already show you what is the priority here, 32769. What is the priority here, guys? What is the priority? Priority is 32769. Clear na? And I already told you, bridge ID is made up of two things, priority plus MAC address. First of all, route switch will check, guys, priority. And by default, priority is 32769. Getting my point? Yes or no? Right na? Yes. Clear, guys? Everyone, anyone here who do not understand, let me know. Done na? Okay. Now, what I did, I go here and I am writing spanning tree VLAN 1 priority 0. I configure this switch priority 0. See here. What I did, I configure this port priority is 0. Everyone see very carefully. Show spanning tree VLAN 1. What is the priority I set here? 0. But it's 1. Why? I hope you guys know. Because of one feature. Right now. This become 1 because of one feature. Okay na? The name of that feature is, I hope you guys know. Right? Okay. Because, guys, by default on this switch, VLAN number 1 is there. VLAN number 1 is there. Right now. Show spanning tree summary. If you write, see, there is a one feature. The name of that feature is, I hope you guys are able to see here. Yes, extended system ID. So this is the name of the feature. What this feature will do, it will add the VLAN ID with your priority. Fine. So I configure the priority 0. And by default on a switch, VLAN number 1 is there. So 0 plus 1. What is the priority? 1. So that's the reason you are able to see priority 1 here. Getting my point? Done, everyone? Yes or no? Right? So now see, this bridge is now become root. It means now, once I change the priority 0 on this switch immediately become root bridge. But you already configured one feature. What feature? Root guard feature on this switch. So when you change the priority, this switch send the BPDU reach here. Immediately these two ports goes down because this switch is not expecting any better BPDU on these port. But now this switch is receiving the better BPDU. So immediately these switch convert these two port in which state? That is called root inconsistent state. I can show you. See guys. Show interface fast Ethernet 0 by 1. So once you will see it is showing up, but it should be disabled. It is, guys, basically it is in root inconsistent state. That is called root inconsistent state. Are you getting my point, everyone? Yes or no? Everyone, tell me. I hope you guys understand. Do you guys understand? Tell me. Yes. Okay. Yes, these two ports are, guys, in root inconsistent state. I don't know in packet tracer we can run or not. Let me try. So spanning tree, there is a command. You can run this command, but I don't think it will work. Inconsistent port. See, are you able to see? Inconsistent port. It is telling now fast Ethernet 0 by 2 is an inconsistent port. Show interface fast Ethernet 0 by 2. Here we can't see. Here we are not able to see. Right? Here we are not able to see. But once we are writing this command, we are able to see here. Fast Ethernet 0 by 1, fast Ethernet 0 by 1, fast Ethernet 0 by 2. Both are guys in consistent state. Both are called guys inconsistent state. Getting my point, everyone? Yes or no? Right now. So what is the solution? What I told you, what is the solution? What is the solution? For example, I go on this switch, enable conf t interface fast Ethernet 0 by 4. I'm writing shut. I shut down this port. So once I shut down this port, it means now this switch is sending the BPDU, but this port is now down. It means now this switch is not receiving the BPDU here, guys. Yes or no? Tell me first. Right na, everyone? Yes na? Yes. On these port, switch is not receiving any types of BPDU now. Getting my point? So conf t interface range fast Ethernet. See na, we do not need to write any other command, guys. Now this port is getting in the forwarding state. Coming in the forwarding state, guys. Yes, see, now both port comes in the forwarding state. I hope this is clear to all of you, everyone.